So we're going to resume with lesson 11. We've written our first, not very useful unit test here. We're going to write a test that's maybe slightly more meaningful. So after our first test, we're going to add a second test method decorator. We're going to call this index loads index view. So the first parts of our test will actually be the same. Our arrange and act, those are largely going to be the same. So we're going to instantiate our controller, we're going to call the index method, and we're going to get a result back. Our assert this time will be a little bit different. So we're going to assert, and we're going to use this r=equal method. It's going to be pretty common in unit tests. And r=, take two parameters. What did we expect to get? What did we get? And are they the same? So we expected a view called index. And instead we got back, we want to check the result dot view name. And we want these to be equal. Now, when we do this, we do have a bit of an issue here. It says our result that we got here on line 29, our result doesn't have a view name property. So let's look at why this is. So our method, our index method, look what it returns. It returns an iAction result. And within iAction result, we return a view. So why are we getting this error? The issue is, in this case, the method returns iAction result. We must cast it to the child class view result. So iAction result is a parent class. It's an interface. There are different kinds of iAction results. There's views, there's redirects, there's JSON, there's HTTP status. In order for this object to have a view name property, we're going to have to do a cast. So we're going to call the method, but we're casting it to a type view result. So that solves the error down here and creates another error here. Our unit test class has no knowledge of what a view result is. So we need to add a reference to .NET Core MVC. Once I add that reference, now my live unit testing is suggesting this will fail, but I'm going to run the unit test and see. So I could go back to my test explorer. I could run it from my test menu. I could even run the unit test from here if I want. I can just click my little blue icon and choose run. It doesn't matter how we invoke the test. So when I run the test, it tells me it failed. Yeah, I like that, live unit testing. So it says assert r=, failed. It expected index, yet our view name was actually null. So this property, this view, had no name. So this is a case where our unit test is going to help us write better code. So as it is right now, we would have expected this to pass. However, we're missing a couple of things. Number one is we don't actually have a dummies index view, do we? We go to the browser and go to global grub and try /dummies. The view doesn't even exist yet. So first of all, we need to build the view. And then we can try our test again. So I'm just going to right-click my method, add an empty view, and I'll just leave the name as index so that it matches our method name. So this is a dummy page for testing. I just right-clicked the controller and chose add, right-click the method name, chose add view. And then it will create it inside of views, dummies, and the file name is index. So now the page loads. So we fixed the error, first error in the controller. Now I can go check the unit test. Well, did the unit test pass? And go to the unit test. But if I run it, and it's still telling me it failed, our result view name is null. So the unit test is going to help us write some better code here. We know that this method actually works in the browser. I can go call this URL. I can invoke the method and it loads the view. So why do you suppose this is failing? Why is our unit test failing? There's something we should do in our method to ensure that we are loading the correct view. We actually did this in our very first class. Okay, it's good, Alex. What the unit test is suggesting is we need to be more intentional about which view should be loaded. Yeah, we're going to name it directly right here in the return statement. That's right, Manjinder. So return view is overloaded, right? There's 4 different methods. So if I save that, it's now the live unit testing is saying, yeah, this is probably going to work now. I can even run my unit test right from here. I'll run them. And now that fixes it. So both tests that we have are passing. So this is going to be a little gotcha because in all of the code that we scaffolded, wherever there's a return view statement, the name is implied, but it's not listed explicitly. So in your assignment, I've mentioned this, right? In whatever method you choose, in the return view statement, explicitly provide the name of the view as a string. Well, Scott, the files, obviously, they have to have names, but it's saying the unit testing doesn't like this kind of convention that the name is just automatically taken from the method name. It wants us to be more intentional about specifically which view is loading. So now we've got 2 passing tests. We're going to add 1 more line of code to the method and write 1 more unit test. And then we're going to move on to starting to unit test our products controller, which is going to be a little more complicated. Let's also here put a variable in view data. So I'll create a variable called message. It says this is a view data message. And then we want to display this variable inside of the view And then we can unit test for it as well. Doesn't really matter what string you use here, just some string. And then if we go back to our view, I'll put on a paragraph tag, and I will output that message variable. Oops. Okay, so now we've got some text here. So again, here it is in the controller. I've added line 14. And then I just output my view data message variable in a paragraph tag. So we can write one more test to verify that our view data message variable has the correct data in it as the string we're expecting. Again, we output it inside of paragraph tags, prefix with the @ symbol. And now we can write one more test. Again, we'll use our test method decorator. So we'll say index view data shows message. Our arrange will be the same. Our act is going to be the same. I'll cast. So same 2 lines as in our previous test, but our assert is going to be different because we're checking something different. So what we are checking is this message. This is a view data message. That's what we expect. So now I can access the view data property. So we're checking that the view data is equal to this string. I'll run my test, which passes. Okay, so we've got three unit tests. They're all passing. So the goal when we're testing is all of our tests should pass. Now, we've been a bit repetitive in the arrange statements here. Everyone, we've got the same arrange statement. There is a test initialize, a special method that we'll use in our next set of unit tests, so that if we want to run the same setup for every method, we can move that code rather than duplicating it, replicating it over and over again. We could move this line into a test initialize method. I'm not going to do that here just to keep it simple, but we will do that in our next unit testing class. Okay, so there was just a really simple example of unit testing a very simple class with one method in it, right? We're not working with any data. Or really different set of conditions. We're just starting off nice and simple. Are there any questions about this particular class so far? We're basically done with this one. Okay. So let's go, and we want to start unit testing our products controller. Okay, that's good. Thank you for the feedback. So inside our test project, No, now we need test method over each one because we could actually have methods here that are not unit tests. So test method indicates this is a test itself. So I'm going to right click my project. I'm going to add a class here. Now the template we want isn't actually here, so we'll just call this products controller tests. So call your class products controller tests. We need to add the test class annotation, which gives us an error and prompts us to import the Visual Studio unit testing tools. And then all our code will go in here. Now, one thing, when I created this class, notice here's our original unit testing class. It has a public scope. If we create a class, a generic class, it's not public by default. And if the class isn't public, the Test Explorer can't find it. So unless our class is public, we won't be able to run our unit tests. So that's a gotcha in your assignment. If you're creating a test class, make sure you define it as public. I will put a note in here to that effect. So let's start out to just run a simple test, kind of similar to what we did here. We want to maybe check that when you call the index method of the products controller, you get back a view called index. So let's start there. So we'll create a test method. Index loads index view. So we'll arrange, act, and assert. Now I'll arrange in here for now. We're going to move it to an initialize method after to avoid duplication. So let's try and instantiate an instance of the products controller. Now this class is going to need a reference. So again, we have to reference our global grub controllers. So it references, we've added the reference, but now we still have an error. So that's kind of weird, right? Why do we have this error even after we've referenced the global grub controller's namespace? That's right, Alex. So if you notice, this worked fine in our dummies controller. Yep, it has to do with dependency injection. Exactly, Attila. Thank you. So in our dummies controller, there's no constructor necessary. There's no dependencies required to create our dummies controller. It's empty. It doesn't require anything. So we could just instantiate it without any parameters. But if we look at the products controller that was scaffolded, right, here's our constructor. Whenever we scaffold controllers with Entity Framework in Visual Studio, those controllers use dependency injection, right? They take as a parameter a database connection object. So because of this dependency, we can't instantiate a products controller without passing a database object to it. Now we're unit testing, we're not integration testing, so this creates a bit of a challenge. Right? We don't want to connect to our SQL Server database when we're unit testing. We're trying to test the application code only without a third party connecting out to SQL Server. So we need to do a few things in order to make this work. Because all of the methods, all of the unit tests in this class, they all are going to need to instantiate the products controller and pass in database object. I'm better off to move this part of the arranging into an initialize method that can be called and shared. So we're going to need to do some setup here. First thing we need a substitute for our database. We're not using SQL Server. We're going to use a library that we're going to install that will allow us to create and use an in-memory database. It's kind of like HTML5 local storage. So we're going to create and populate that database in memory just while we're unit testing. So this way we can test our controller methods without having to connect to our SQL Server database. So you click on Tools and NuGet Package Manager, and let's go to manage the NuGet packages for the solution. Click over to the Browse tab, and we're going to search for in memory, all as one word. So what we want is this library here that's been downloaded 88 million times. We want Microsoft's .NET Core in-memory library used for testing. So I'm going to click on it. Now, because we now have two projects, we get prompted, well, there's another common library that I've used in some older lessons called mock, also very popular for mocking the data. I used to use it. You'll see lots of documentation using mock. I actually think the in-memory database, the code's a little simpler. It basically does the same thing. So I'm going to have to pick a couple of options here. Number one, check off your test project. We don't need it in the web project. We only need the in-memory database available in the test project. The other thing is the latest stable version is .NET 6. That's for .NET Core 6. So pick any version that starts with a 5. I think there's a whole bunch of them. So pick version 5 point something. I'm going to pick the latest .NET 5 version, which is 5.0.12. So I've checked off my test project. I'm installing a 5+ version and just click install. So now in my test project, we can see I've installed the in-memory dependency. So I'm going to add some code here. So these will be our class level vars shared by all tests. So I'm going to declare an instance. Sorry, show the DB context. Now I'm not sure which file you want to see. In the data folder here. Yeah, we're not going to need to make any changes here. Instead of passing this, we're going to create one in our test class. Okay, so we're going to create an instance. In order to use this, we've got to reference the data folder. So that out of reference on line 2. I'm now going to instantiate the controller. Actually, I'm just going to declare it here. Yes, that's a good point, Scott. So we're going to declare an instance of our controller, but we're not going to instantiate it yet. I'm going to take So we've got those 2 class level variables, and then we're going to set up a test initialize method. So this runs automatically before each test. Just drag that comment up here. So before each test, we want to create in-memory DB. So we're going to set up the options for our database, and then we're going to instantiate it. We're going to set up the options on our application DB context. We're going to use an in-memory database. And whenever we do this, the in-memory database, it needs to have a unique name. So we can use a GUID for this. We'll uniquely name and again, we're going to need to make a reference here to Entity Framework Core in order that it recognizes this DB context class. Now, this code is actually similar to the code we have in our web project startup file, except instead of the use in-memory database, we have a call to use SQL Server using our default connection. Well, I'll show you that code in just a second. So we're setting up the options for our in-memory database. We actually look at our web project startup file. Here, we're adding the DB context. We're setting the options, except in this case, we're saying use SQL Server. So that's for the web project at runtime. For us today, we're not using SQL Server. We don't want to do integration testing. We're using our in-memory database. And then we can just instantiate. So we're setting up the options, giving it some kind of unique name. And then the database object actually gets instantiated and created on line 29. Once we've done this, once line 29 is run, now we can instantiate an instance of the controller, and we have the dependency we need to inject. So now we can instantiate controller with DB dependency. So we'll call new. And now we can pass in our context variable. So the instantiation is now going to work. But you can't create an instance of the products controller if we don't have a database to give it. The products controller can't do anything if there's no active database connection. So now we should be able to write our unit test. The arranging is now done here automatically. So again, we're going to call Scott. Yeah, I think you can use SQLite. But again, is that unit testing? I don't know, because with SQLite, you're still, it's not quite in memory. Normally for unit testing, it's recommended to use mock or the in-memory database, so that the data lives within our application itself. It's not external to it. So again, we'll now call the index method our view result, just like we did in our other controller. In order for this class to be recognized, we need to reference .NET Core MVC. Now we got another issue. That's kind of weird. This is the exact same code. If we look here at our previous unit test, it said var result equals view result controller index. If I copy those two lines, they're identical. Yet it worked in our other unit test, but it's throwing an error for us here. Any idea why? If you take a look at the index method of the dummy controller and the index method of the products controller, okay, well, Yulia, we do need to add that. Yep, that's true. So let's do that. That's one issue. So in the products controller, here's our return statement. Yeah, Attila, we'll come to that in just a second. But Yulia, yes, you're right. We should be adding here, before we pass the data model, we also want to explicitly, the first parameter is a string, right? We're going to call the fourth overload the view name first, and then the data model second. So yes, for sure, we should be adding the name of the view as our first parameter. That's a good point. That's actually not why we got that error, but we will need that. Okay, Attila, can you explain? He said, async task action result. Can you explain a bit more?
Different result type, because we wanted an I action and is enveloping the task.
Thank you very much. The return types for this index method that we got from scaffolding writes asynchronous code, which is designed for better performance. So notice it returns an I action result, but actually returns an asynchronous task of type I action result. Whereas in our dummies controller, we just wrote synchronous code. There's no async or task. So the code, the unit test that we wrote here, it works when our controller returns an I action result. But when our controller returns an asynchronous task of type I action result, code doesn't quite work. So we'll need to modify it just a little bit. Here, we now need to access the result property. So we've got to add this dot result at the end. That allows us to read that asynchronous task and then cast to a view result. Now the assert statement should be the same. So we're asserting that we are expecting the string of index, and we are going to compare it to our result dot view name. And as Yulia mentioned, our test will fail unless we change that return, right? Our view name must be specified explicitly as a string now. So my live unit testing indicates my test is likely to pass. I will run it. And my test passes. if I go and look at my code coverage, I'll run that tool again for just a minute. And I'll expand my controllers, and now my products controller is 5.5% covered. Here's index. So interestingly, it says our index method is 100% covered. And if I go to the products controller, it says we've covered the constructor. It says we've covered index 100%. This is a little bit misleading. Right? We're checking that we got the correct view name, but there's also another unit test that we need to properly test this method. We know we're getting the right view, but what else do we need to test here? The code coverage doesn't really give us the full story. Thank you, Yulia, right? The main point of this method is not only to load the view, but that we can actually see the products as well. If I log into the site as an administrator, it's not only that it loads the index view, but I actually get the product data being displayed. So even though code coverage says, yeah, you're 100% done, we're not really done. So let's also write a test method, index loads products. Again, we're not going to need any arrange here. We're just going to need to act and assert. But in order to do this, we now have to create some data. We need to create a list of products that we can use. And we're going to need that fake list for our other unit tests too. So we have a database. We're creating a database here, but there's nothing in it. So we need to populate some mock data. So I'm also going to create a list of type product called products, which is going to be equal to a new list Now we'll get a reference error here. Our class doesn't know what our product class is, but if we reference our global grub.models, it goes, oh, okay, I know what a product is. So again, we're going to make this a class level variable so we can access our kind of mock product data from any unit test. So we're creating the database here. We're creating our controller and passing it the database down here. So in between, before we instantiate the controller, populate DB with mock data. So I'm going to create first the category. We'll give it a category ID, and we'll give it a name. And then we'll create a few products that belong to this category, because every product has to have a parent category reference. So I'm going to create 3 new products. We're not going to worry about the product photos. This one. I'll maybe create 3 different products. Okay, so you can use this object as a template. And I'm going to change the values on So create 3 products and make sure you give each one a unique ID and a different name. Doesn't really matter if the price is different. They can all be in the same category. So make up ID numbers of your own. Make up your own product names. And now we want to add all of these objects to the database. So we're going to add each product. And now, just like in our controller, we're going to call save changes. So when we call save changes, this is what actually populates the database. Okay, so all this code before it, we're creating a category in memory. We're creating 3 products in memory, but now we're committing them to our in-memory database here on line 72. So now when we instantiate our products controller, the database object we're passing it, it has these 4 records in it in memory. So this data setup, we only have to do it once. Probably the most complicated thing we're going to do today. So you will have to mock up data for your assignment in your own controller. And then you'll save the changes, you'll commit that mock data to your in-memory database. Yes, I think so, Attila. Thank you. Yes, we should add it. Nice catch. I appreciate that, Attila. Thanks for that. I added line 40. It's great having such smart students. I learn as much from you guys as you do from me. Okay, so create the category, add it to the categories DB set. Then add the 3 products, add each of those to the products DB set, and then we call save changes when we're all done. So we can write our unit test, and then we will take a break. So we don't need to do any arranging. because all the arranging we need is already done in test initialize. We can just act and assert. Again, we'll cast as a view result, controller.index.result. But in this case, we actually are interested in we'll do it this way. So we'll run it. We'll create a model that's of type list product, and we'll set it equal to list. We'll cast as a product list our result dot model. Okay, so we're taking the data model in our view result, and we're casting it, right? Because our model should be an IEnumerable, a list of products. And now we want to check that our model is the same as our products variable. They're both lists of type product, so they should be the same. So we're comparing two lists together. Our assert is a little bit different when we're working with lists. Instead of assert, we're going to use collection assert. So we are expecting to get our list of products. We actually got our model. So it suggests this is likely to work, but I'm going to run the tests and see. And it says, cool, our tests pass. Now, just to check this, I can actually use my debugger. So if I put a breakpoint here on my collection assert, I can right-click my method name and choose Debug Test. So I can actually watch it execute. So when we get to here, it says there are 3 products and 3 items in the model. And when I expand my products, product 0 is delicious food. Product 1 is special sauce. And product 2 is the best taco seasoning. So they're actually in alphabetical order already. Because inside our model, we are also sorting alphabetically. So delicious food is first. Special sauce is second. And the best taco seasoning is third. Now, maybe what I'll do, I'm just going to do one more thing with this. Sorry, 2 more minutes. I'm actually going to just rearrange these a bit. I'm going to make this product first. My third product, I'm going to drag it up to the top. If I do this, my live unit testing actually suggests the test is going to fail now. If I reorder these, so if I reorder these, my test that passed before, it now fails. And it says element at index 0 do not match. So how come it fails if I shuffle the order around of our mock data? So it worked the way I had the products listed the first time. As soon as I moved one, it now causes my test to fail. This is actually good. No, it runs in memory each time. So each time you run the test, it creates the database again. Well, again, I could use my debugger to see. So my list of products, I still have 3 products, but the first product now is the best taco seasoning. The second product is delicious food. The third product is special sauce. But in my model, delicious food is first. So it says the elements at position 0 don't match. Emra is exactly right. Because in our model, we have an order by. We are ordering the products alphabetically by name. So we have the same 2 lists, but they're in different orders now because our controller expects a sorting. So not only should we be ensuring we get our list of products, but to test our method, we should be checking that the products are returned in alphabetical order, like they are here. So I'm going to add sorting into my assert. We expect not only do we expect to get all the products in the products table, but we should be getting them in alphabetical order. So if I add my order by, this should fix the unit test. So now our test should pass regardless of what order we populate the database in. When we call the index method, we're not getting the products in some random order or by the order they're entered in the database. We are getting them based on alphabetically by name. So that fixes our test. Okay, I'm going to push. This with mock data. Okay, it's almost 1 o'clock. We've got 4 more tests to do today, but probably the hardest part we've already done here. So the test initialize, setting up the whole mock database, probably the most complex part. So when we come back, what we're going to do is deal with the details method, because we looked at this early in class and we said, what are the different outcomes of details and how many tests would we need? So we will unit test our product details method. We'll need 4 tests, and then we will call it a day. Okay, let's take a 10-minute break here, and we'll be back. So we'll make it 12 minutes. We'll come back at 10 after 1.